Hello everybody, today's video is on ensemble algorithms in machine learning, and we'll deal with the bagging, boosting and voting techniques in ensemble. So what is ensembles? These ensembles, they are used for improving the accuracy of the model. Or I can say that I want to improve my accuracy for better predictions so that my model is able to predict on unknown data with good accuracy. So after training the model, what comes is that if there's some improvement, some scope for improvement, I will use these boosting techniques, these ensemble techniques. So there are three most common ensemble techniques. First is bagging, boosting and voting. See, all work on the same underlying principle, that is voting mechanism, but there are few differences. Let's see. Bagging and boosting. So all use voting and they combine models of the same type. Okay, because in voting you will combine the models. Now bagging, as you can see here, this is parallel because every model is treated individually. Okay, but in boosting you see this is sequential, so the new model inherits the performance of the previous one. Okay, and in bagging, weights are given, like models are given equal weightage, but in boosting it is not so. The weight of a model is dependent on its performance. Okay, so boosting is much more efficient here as compared to bagging, but it depends. Okay, so now let's see the bagging algorithms. Now bagging is also called bootstrap aggregation. Now why is it called so, we'll see. Now what happens here is, you see this is your sample data. Okay, what happens, I will divide it into different various samples. I call it as resamples. So I take this multiple samples and I put them into my models. These are the models, like either BDT, back decision tree, random forest or extra trees, and then I will make a prediction on that. And this prediction is based on the voting. Suppose this model gives me 1, this model gives me 1, this gives me 0 and this gives me 1. Now what happens is the majority is 1, so I will get the prediction as 1. Okay, so this is what is bagging, wherein I take multiple samples and this goes through a training model and each gives me prediction and this is voted upon. Okay, this final output is then averaged across the predictions of the submodels. Now let's see the bagging models. First is back decision tree or BDT. They perform best with algorithms that have high variance. High variance means the spread of the data is huge, so that you can make very decision trees. Okay, random forest is an improvement of the decision trees. As you can say, it is a collection of many trees. Okay, so you see this decision forest, random forest, sorry. Now what happens here is, there are different models which have been created and they predict. Now you see here the prediction 1 and 0. So 1 predict 1, 2, 3, 4, 5, 6. So you can see that 6, 1. Okay, and there are 3, 0. Predict 0, predict 0, predict 0. So you can see here there are 3 predict 0 and there are 6 models which are predicting 1. Okay, so now in random forest what happens is, this is, I can say it is an extension of BDT, and the samples of the training data that are taken with replacement means some data of this model can come in this model also. Now these trees are constructed such that correlation between different classifiers is reduced, but with replacement also I will not have this correlation. If this correlation has to be reduced so as to improve the prediction, so that it is not dependent on any other model. Now what happens is, the prediction will be 1 because the voting is 6 for 1 and 3 for 0, so you go for majority votes. Extra trees are another modification, and here what happens is, the random trees are constructed from samples of the training data set. Again, an improvement of this further models worked on the same principle of majority voting. Now boosting algorithms. Boosting works with the sequence, okay, in a sequential manner. This creates a sequence of models, and the previous model corrects the, the subsequent models correct the mistake of the previous one. Okay, so What happens after that? The model then make predictions and results are combined again to create the final output predictions. Okay, again the same thing that it works on these, combining the results and predicting the output. The only difference is that it works with sequence of models, not in parallel. Every model is not treated in isolation, but they are being connected. Now, two common boosting ensemble algorithms are AdaBoost and stochastic gradient descent, or it is also called gradient boosting machines. Now let's see AdaBoost. Now this is the most widely used and popular ensemble algorithms. What happens in an AdaBoost is the parameters which I'm working with are being given more or less weightage. Okay, and the parameters which have the less weightage are being left, and which have the high weightage are being taken to build the subsequent model. Okay, so the model identifies that which all parameters are important for the model, so it chooses it and it builds the model. Now, stochastic gradient boosting, this is the most sophisticated ensemble techniques, and it gives very good boosting results, and it improves the performance of model, and your model can predict with good efficiency and accuracy on unseen data. So we will see in our practical videos on how these work with the code. Next, last is the voting ensemble. This is very simple. This is the basic of all how bagging and boosting works. And what happens is this simply combines the prediction from multiple machine learning models from your data, and this creates what two or more standalone models from training data. These models are then what happens, one model then wraps it, make prediction, this averages the prediction of all the submodels and gives you the prediction. Okay, again the same thing, that every from a data set different models, the submodels will be making prediction, and then they will be combined. So this is what Ensemble will be doing to boost the efficiency of your model. Okay, so that's all for this video, and in the next video we will see further things in machine learning which we can learn. So stay tuned. Thank you.